We ended our last video talking about properties of ionic compounds, and you can review that on the previous video. We are going to move forward and we're going to talk about how to name ionic compounds given a chemical formula. Naming ionic compounds is pretty simple. All you need really is a periodic table. There are 3 easy steps. The first thing you're going to do is you are going to name the metal, or the cation. Okay, so you're going to look on the periodic table and you're going to find the metal. And you're going to write its name down. The next thing you're going to do is you're going to name the anion, which remember will be your non-metal. Now the thing about your non-metal is that its name does change a tiny bit. We are going to change the ending to the anion to say IDE. For example, if we have fluorine, it changes to fluoride. Chlorine changes to chloride. Bromine changes to bromide. Iodine changes to iodide. Oxygen changes to oxide. Sulfur changes to sulfide. Nitrogen changes to nitride. Phosphorus changes to phosphide. And hydrogen changes to hydride. I did leave out a couple of elements, such as group 18, and that is because group 18 does not create chemical bonds. Group 18 does not create chemical bonds since they are the noble gases, therefore their names will never change. So let's look at the following. We have BAS. We're going to find Ba on the periodic table, and it is barium. So we write down barium, and we don't change anything about its name. And then we're going to find S on the periodic table. That is sulfur. And sulfur, since it's in a compound, its name changes to sulfide. So we will have barium sulfide. Next we have magnesium and fluorine. Together as a bond, it changes to magnesium fluoride. Magnesium fluoride. As you are going through these, there's no excuse to misspell these metals because they're given to you on the periodic table. So don't be lazy. Just literally copy them from the periodic table. Now with your non-metals, it might be a little bit more tricky, but they're still not bad. You're just taking the ending and changing it to IDE. Next we have Ca3N2. So we're going to look on the periodic table and we find calcium, and we have nitrogen, so it changes to calcium nitride. Now, if we have more than 2 elements in our chemical formula, that should be a red flag, an indicator that we have a polyatomic ion. With your polyatomic ions, they're even easier than with just regular nonmetals, because all you have to do is look at your reference table on page 7. Page 7. It's going to have all of your polyatomic ions listed up there. So you're going to follow the same steps, meaning you're going to name the metal first, and then you're going to name the polyatomic ion. And you simply just write its name directly from the reference table. You don't have to do anything else. Just look at it in the reference table. Do not change the ending. So say, for example, we have NaNO3. Notice how we have 1, 2, 3 atoms, or 3 elements here. But with naming, you will only have 2 names for the most part. You should never at any point in time have more than 2 words written down for your name. So for example, we have Na, which is sodium, and then we're going to look in the reference table on page 7 and find NO3, which is nitrate. Okay, so again, you only have two names, two words, sodium and nitrate. You should not write sodium nitrogen oxide. That's 3 words, and that's 1 word too many. So only 2 words. So let's look at these. We have KOH. Again, I see 3 elements here, which should be a clear indicator that we have a polyatomic ion. K is potassium. OH, if we look in the reference table, is hydroxide. Next we have NaC2H3O2. We have a ton of elements in here. We have 4 elements in here. Yet we're only allowed to write 2 words. So we're going to find Na on the periodic table, and it is sodium. And we're going to find C2H3O2 in the reference table, and it is acetate. This next one's a little bit different, only because I do not see a metal here. But that does not mean that I don't have an ionic compound. One giveaway are the parentheses. These parentheses indicate that we have a polyatomic ion. So we're going to look in the reference table and we're going to find NH4 on page 7. It should be the very first one on page 7. Its name is ammonium. And then we have oxygen. Oxygen, when it's paired up with another compound, is called oxide. So the name of this is ammonium oxide. And finally, the very last example down here, again we see 1, 2, 3 elements, clear indicator that we have a polyatomic ion. Another dead giveaway is your parentheses here. So that means we have a polyatomic ion, and we're going to look in the reference table and we're going to name this compound. We have Sr, which is strontium, and PO4, which is phosphate. So here we have strontium phosphate. Like I said, your polyatomic ions are given to you in your reference table, but there are 5 that you need to know without looking, only because we're going to use them so much. We have nitrate, which is NO3 with a -1 charge. Sulfate, which is SO4 with a -2 charge. Carbonate, which is CO3 with a -2 charge. And acetate, this guy can be kind of tricky. He has 2 different formulas, yet they are the same, meaning here we have carbon and there are 2 atoms of carbon. If we look over here, we also have 2 atoms of carbon. They have just been rearranged a little bit. We have hydrogen, and there are 3 of them. Same over here, 3 hydrogens. And we have 2 oxygens. Same over here, 1, 2 oxygens on this side. They're the same formula, just prepare yourself to see it either way. And then we have ammonium. Ammonium is important because it is the only one that has this positive charge. So it has lost an electron here somewhere along the way, which is why it has a +1 charge. So we've lost an electron somewhere. And that will be the end of this video. Please take the opportunity to work on your writing names on your assignment. And in the next video, we will talk about writing ionic formulas.